Welcome to your preview of Training to Go course material that carry NETA, International Electrical Testing Association, Continuing Technical Development Credit. This overview will explain the value proposition and the functionality of this training. Now let's get started.
Hi, I'm Tom Basilise. I've worked in the electrical industry for over 40 years. During that time, I worked for a major electrical manufacturer, as a distributor, and as a salesman supporting distributors. These modules are a result of utilizing lessons learned in those capacities. I designed these modules to provide product knowledge for all levels from beginner to expert. As we go through the rest of this introductory module, you will get an understanding of how the modules work and how they will provide value to you. I look forward to working with you to implement this training for your business.
Presently, 14 courses have been approved by NETA, totaling 20 CTDs, Continuous Technical Development Credits. These are busway and bus plugs, contactors including lighting contactors, electrical fittings, insulated case breakers, which is highlighted by a video that shows the breakdown and buildup of an SPB breaker, low voltage motor control, low voltage power breakers that includes dynamic wiring diagrams of every type of breaker control scheme, low voltage and medium voltage fuses, medium voltage control, which includes part number breakdowns of all major medium voltage contactors, medium voltage switchgear that demonstrates the features of a double init substation while explaining typical symbols seen on a one-line diagram, molded case circuit breakers, motor control centers including every brand of motor control center, protective relays, transformers covering every transformer from control transformer to liquid-filled transformers, and variable frequency drives covering the various types of manufacturers of drives. Outlines of each course content are available on the TS&C website. These courses are eligible for NETA Continuing Technical Development Credits, CTDs. NETA Certified Technicians Level 2 are required to earn 24 CTDs, while Level 3 and Level 4 are required to earn a minimum of 48 CTDs every 3 years to maintain their certification. For more information about the CTD program and requirements, please contact the NETA office at neta@netaworld.org or 888-300-6382. This is a perfect opportunity for technicians to obtain 20 hours towards their required CTD to maintain their certification. There are 6 additional Training to Go courses which one NETA company labeled ideal for new hires. These include component evaluation, electrical test equipment, fire safety, ladder safety, lockout tagout, and operators devices, which explains the various types of pilot devices and switches. These courses are included at no additional charge, and outlines can be found on the TS&C website. Our Training to Go courses provide more bang for the buck. They can be utilized for day one training of new hires. It can supply prerequisite training for certification testing. It also allows test-taking practice and preparation for the certification testing. And at your own pace, you can combine certification preparation and earn CTDs. This 4-step process is easy. First, take the Training to Go courses. Next, take the certification exam. Then, after receiving the certification, retake the Training to Go courses. Lastly, receive your certificate of completion to submit for your CTD credit. Let's touch on the value these courses provide to your business. It is important to indicate that these are not just videos. They are dynamic, student interactive online learning courses that require input from the student. Animated illustrations are used to provide reinforcement for the learner. Every module ends with a selection factor screen indicating the information needed from your customer in order to supply the correct component. Small sections are followed by assessment quizzes in order to determine if the student understands the material. At the conclusion, a certificate of completion is issued as proof for continuous technical development. Student course completion is captured on a spreadsheet which managers are given access. These courses also qualify as prerequisite hours toward technician certification testing requirements, as well as the previously mentioned NETA CTD credit. Some businesses have found it helpful to use this as part of a sales promotion tool for these products. In these cases, the student takes the course, then is challenged to sell and promote that product for the month. This usually includes a financial incentive for the student for any incremental sales. Here are some typical examples of the dynamic illustrations used in the Training to Go modules. Let's now go over the operation of a quick close breaker and see how the diagram works. With the control voltage applied, the motor is energized through the G-switch contacts and charges the closing springs. When the springs reach the fully charged position, the mechanically operated switches change state. When the switches operate, the G-switch opens and stops the motor and the F contacts close, preparing the breaker for the closing operation. Next, the closing signal from either a closing switch on the breaker cover or from a remote push button or a secondary device energizes the X relay. Next, the closing relay CC closes. The prop roller is released and the closing springs discharge and close the breaker, making the primary moving and stationary contacts meet. At the same time, the closing relay contact D closes to energize the anti-pump relay W. The E contacts reverse their state, providing an anti-pump feature, and the X relay de-energizes. The anti-pump relay feature allows one closure of the breaker for a single operation of the closing switch, no matter how long the switch may be held closed. When the breaker closes, the mechanically operated G switch is closed to energize the motor again, and the F switch is open and de-energize the control relay. The auxiliary switch contacts open, preventing the control relay X from energizing until the breaker is tripped open. With the G contacts closed, the motor charges the closing springs, ready for the next closing operation. The thermal overload protection functions in the same manner as a bimetal overload relay in a motor starter. It includes both bimetallic and magnetic elements. The standard thermal magnetic breaker includes the combined elements as shown in this diagram. You can see how the bimetal heating element is connected to the trip bar. If there's too much current in the system, the bimetal will heat and bend. At this point, the breaker contacts will open. Now that we establish what an electronic trip unit is, let's explain the settings that are available. Every breaker, when installed, has a trip curve based on time and current, as seen here. Let's go over how that curve gets its shape. You may have heard of the designations L, S, I, and G when selecting a trip unit for a breaker. We will start with the L first. It stands for long time setting. It allows for long time setting for the thermal portion of the trip curve and is set as a percentage of the breaker rating, usually 40 to 100%, and allows for a time delay setting in seconds. The blue line here will demonstrate the adjustment available. The curve can be moved in and out along the current axis, as well as up and down on the time axis. Next is S, which stands for short time. This setting is associated with the magnetic or short circuit setting and is set as a multiple of the breaker rating, usually 1 to 10 times, and can be bypassed for just an instantaneous setting. It is represented by the red line on the curve. It too can be moved in and out along the current axis and up and down along the time axis. The I covers the instantaneous setting. It involves the magnetic portion of the curve, represented by the yellow line.
It allows for adjustment of 1.5 to 12 or 13 times the reading. Lastly is G, which represents the ground fault setting, which covers the settings for the low-level currents to ground and time delay settings shown by the green line on the curve. This flexibility allows the customer to coordinate the protection needed for all circuit breakers in the building system.
When you first see a single line diagram, also known as one line diagram, it can be overwhelming. Since it is crucial to working with or understanding medium voltage switchgear, we'll spend some time breaking it down so it will become easy to interpret. We will also zoom in on symbols and ANSI device numbers and explain their meanings. It is important to note that the power flow shown only represents one phase of a three-phase application. This diagram is an excellent example to show power flow because it is superimposed over a structure lineup, giving a better indication of where components are located. First, let's do an overview of what is being displayed. This is a 7-structure medium voltage switchgear double-ended lineup with 2 incoming line feeds and a tiebreaker. This is also referred to as a main time main setup. You can see the main breaker for incoming line A in structure 1. The tiebreaker is in structure 4, and the main breaker for incoming line B is in structure 7. You can follow the power flow by the red line from the incoming section through the top or line side of the main breaker, through the main breaker, to the load side or bottom of the main breaker where the switchgear's main bus originates. The bus distributes the power to structures 2 and 3 and then to the feeder breakers. It continues to the top of the tiebreaker. The flow for incoming line B is similar but ends at the bottom of the tiebreaker. Since the tiebreaker is normally open, the power flow or incoming line A and incoming line B are isolated. Now, why would this configuration be necessary? The answer lies in having reliability for the plant. Suppose the power feed from utility is lost on incoming line A. On a conventional lineup, the plant would be unable to operate. However, with this option, the tiebreaker could be closed, allowing the feeder breakers in structures 2 and 3 to receive power from incoming line B. The same process can be accomplished in the event that power is lost from incoming line B. The changeover can be carried out by maintenance personnel manually. A key interlock system such as provided by Kirk Key or Superior Lock is often employed. Typically, it involves opening the main breaker from the affected line, removing the key. The key is then inserted into the tiebreaker to allow it to close. Automatic transfer can occur by using a microprocessor PLC and having the necessary electrical and mechanical interlocks for the proper switchover to occur.
Let's look at the importance of a 100% rated breaker. The NEC, or National Electric Code, section 210.20a, requires that breakers must be derated for continuous loads. Now, if we examine a typical one-line diagram, we can see how this plays out. Feeder number 1 has a total continuous load of 500 amps. Derating it 80%, or multiplying the continuous load times 1.25, we see the load is considered 700 amps. Since there are no 700 amp frame standard breakers, we must use an 800 amp frame with a 700 amp trip. Thus, the cable feeding this motor control center must be sized for the 700 amp trip, making it 2 500 kcmil copper wires per phase. And the motor control center bus must be rated at 800 amps. It is determined that feeder number 2's load is 800 amps. Using the same derating process, we end up using 1000 amps, making it necessary to use a 1200 amp frame and a 1000 amp trip unit. The cable will be sized with 3 400 kmcil copper cables per phase, and our busway would need to be sized for 1000 amps. Feeder number 3 is providing power to a main distribution panel with a 480 amp load. After derating it, we wind up with a 600 amp breaker and a 600 amp trip. The cable feed is two 350 kcmil coppers per phase. As a result, the main breaker must be sized at 2500 amps with a 2500 amp trip. Here's what occurs if 100% rated breakers are used. Feeder number 1 now becomes a 600 amp instead of an 800 amp. The cable size is reduced to two 350 kcmil copper per phase. The MCC bus can now be sized for 600 amps instead of 800 amps. Feeder number 2 changes to 800 amp frame instead of a 1200 amp frame. The cable size is reduced to two 600 kcmil copper per phase, and the bus duct can now be sized at 800 amps. Feeder number 3 remains 600 amps, and the breaker and cable size remain the same. Now the main breaker can be sized for 2000 amps instead of 2500 amps. This is a tremendous savings and results in reduced cost for breakers, cable, and bus.
Some transformers are furnished with dual windings to allow flexibility for different voltage connections in the field. Here's a typical wiring diagram for dual primary and dual secondary windings. This transformer can be connected to a source voltage of 240 or 480 volts, and the secondary can be connected to a load rated at 120 or 240 volts. Here's how. If the source voltage is 480, then H2 and H3 can be jumpered, and the line can be connected to H1 and H4. If 240 volts, then H1 and H3 are jumpered, and H2 and H4 are also jumpered, and the line is again connected to H1 and H4. On the secondary side, if 240 volts is desired, then X2 and X3 are jumpered together, while the load is connected to X1 and X4. If 120 volts is required, then X1 and X3 are jumpered, also X2 and X4 are jumpered, and the load again is connected to X1 and X4. Next up are some examples of quiz questions used in Training to Go. Why not try your hand at answering the questions? This will give you a good idea of how the process works. At the end of the questions, you will see a summary slide showing how well you did. When a student sees this, he can go back and review the incorrect answers. There is no limit to the number of times he can take the course. When a customer calls and needs to buy or replace a piece of electrical equipment, where do you start? A good practice is to have a list of selection factors. I've used this as a training method for a long time. Selection factors are a checklist of what you need to get a customer to tell you in order to provide the correct equipment. At the end of every Training to Go module, one is provided. These can be printed and used as a cheat sheet for your techs and salespeople. The next slide will provide a selection factor list used in the Motor Control Center module.
Now we'll take a look at the selection factors for Motor Control Center units that are starters. We need to know whether it's going to be a full voltage non-reversing or a full voltage reversing, if it's going to be a 2-speed, and if it's going to be a 2-speed 1-winding or 2-speed 2-winding, if a soft start is required, and what type of disconnect does the customer want ahead of this starter? Does he want a circuit breaker, motor circuit protector, or fusible switch? Once the type disconnect is established, it's necessary to know the size of the trip or fuse clip that is required. We need to know the horsepower or the NEMA size, the motor voltage, the control voltage, and if the customer requires separate control or is going to control it by means of a control transformer inside the unit. We also need to know what options or modifications the customer wants. Does he want a start-stop push button, hand-off auto selector switch, on-off selector switch? And for a full voltage reversing application, does he want a forward reverse stop push button or switch? And if any status indicating lights are required, Does the customer require a solid-state overload? Is there extra capacity required on a transformer? The number of auxiliary contacts that are required? And if it's a replacement, we need to know the manufacturer and the motor control center model.
Once a module is completed, a certificate of completion is emailed to the student for their files. Any continuous technical development credits are shown on the certificate. When a student completes a course, their name, course, quiz score, and hours are recorded on a spreadsheet. This information is a vital tool for managers to manage training. Access is provided 24/7 for management. The spreadsheet can be sorted to get an idea of who completed what. In addition, other information can be added such as total hours, cost per course, number of courses to be completed, and the number of courses remaining. This can also be downloaded for incorporation into your human resource file. There are a few different pricing options to fit any budget. Let's go over them now. The first is a 1-year access to all the courses. This is by far the most popular amongst customers. It provides unlimited access and is priced at $3,600. As an example, if you have 10 students taking the courses, it breaks down to only $360 per student. If you have 20 students, the number drops to $180 per student. With 20 total CTDs, it boils down to less than $18 per CTD per student and less than $9 per CTD per student for 20 users. Another method would be to buy single student access for all courses. This is ideal for 1 or 2 new hires. It is a one-time access at a total cost of $360 and breaks down to $18 per CTD per student. Some customers prefer to purchase a single course for their specific needs. This option provides 1 year unlimited access for a single course. The price for this option is $360. Lastly, another alternative is a single student to take a single course. This is priced at $99 per course. Certificates of completion and management reporting is also included in the pricing. If you need something more flexible, just let me know. Be sure to sign up at the end of this demo to receive information on our specials. Here are some testimonial quotes we've heard from our clients. Quality training delivered in a descriptive breakdown for the experienced technician or the new trainee. I know our guys are going to sell more insulated case breakers because they took this training. A Pearl Company owner told us, "Even I learned something." A recent purchase by a NETA customer mentioned, "We are using all of the courses to train our new hires and experienced technicians." Now I'm looking forward to your comments and your feedback. We are extremely proud of a new milestone for our training. Our Training to Go has surpassed 3,000 hours of training delivered and over 2,200 courses taken. If you sell, service, or market electrical equipment, we'd love to add you as a client. We hope you're impressed with this Training to Go preview and now see the value of increasing your tech's product knowledge while contributing to their continuing education requirements. If you would like to audit one of these courses, please click the green box and complete the short form. We will send you a link and login credentials. If your browser does not support this action, open a new tab and enter in this URL. Please note that any or all of these modules can be customized for your company. Do you still have questions? Why not call the training hotline at 856-535-8635. We look forward to your future purchase of our training. Thank you for your time. We should note, by completing the form, you can also join our mailing list to keep informed of specials that we run throughout the year.